capture the perfect video of your dog in stunning 4K, and you want to share it with a friend living in Japan. A raw 4K video file is a heavy digital object. It contains massive amounts of data to render every single pixel in high definition. This animated diagram shows standard internet routing. If you send that giant file straight from your phone in the US across undersea cables to Japan, the transfer slows to a crawl. The data is simply too heavy to travel all at once. But we know that isn't what happens. Your friend taps the link you send, and your dog instantly appears on their screen in perfect quality. YouTube manages millions of these uploads every single day. We are actually looking at a massive system that handles millions of gigabytes of global video data flowing constantly. This instant global playback is the result of a highly orchestrated, invisible logistics network working behind the scenes. The moment you press upload, your video hits a digital entry gate. This gate acts like a security guard, checking your credentials to verify who you are before letting your data inside. This animation shows what happens once you're inside. The system splits your upload. The heavy video file drops straight into a raw storage bin, while lightweight text, like your title and tags, zips over into a fast, highly organized database. Keeping the text strictly separate from the video files means another user can search for a funny dog video and get instant results. The system can read the lightweight text titles without having to haul out millions of massive video files just to see what they are. Meanwhile, that heavy video sitting in raw storage isn't the file your friend will actually watch. It requires an intensive editing process first. In transcoding, the system creates dozens of versions of your original file, resizing each copy to a different resolution, like 1080p, 720p, and 360p. Then, every new resolution copy is sliced into tiny pieces, lasting only a few seconds each. Breaking massive files down into tiny, standardized puzzle pieces is what makes sending heavy data over a weak or unpredictable internet connection entirely manageable. Your friend in Japan is holding their phone, pressing play on your video. The request instantly travels across the ocean to the main server. Here is the real trick. That central server controls the request, but it outright refuses to actually send the video file. This diagram demonstrates the local delivery network. The California server commands a local Tokyo server to hand over the file instead. This local server feeds the video one tiny chunk at a time. If Wi-Fi weakens, it seamlessly swaps high-resolution chunks for smaller ones. By separating the central order taker from the local delivery warehouse, and by using these incredible shape-shifting chunks, the system completely eliminates the need for the video to ever pause and buffer. We still have one missing piece of the puzzle. How did YouTube know to recommend your dog video on your friend's homepage the very second they open the app? It is mathematically impossible for any computer to scan billions of videos and rank them in the exact millisecond a user loads their screen. It doesn't scan them in real time. Recommendation lists are pre-calculated entirely offline, analyzing your friend's past watch history and behaviors while their phone is sitting in their pocket. In this diagram, you can see how those pre-calculated lists are held in a specialized memory system called a cache. They sit there like a prepared menu, waiting to be served the instant the app is opened. The platform feels incredibly fast because nearly every complex computational action you ask for was already finished by the system before you even logged on. Look at this network map. From the initial upload split, through the transcoding slicer, all the way out to these localized delivery hubs. The play button serves as a master trigger for a massive distributed logistics engine that completes this entire journey in milliseconds. Next episode, we'll break down the hidden architecture behind Netflix and Uber. Follow to master system design step by step.